Good morning students. Now we discuss about the chapter 9 integrations. So now we discuss about the definition of the integrations. Definition of the integration means reverse process of derivative is known as antiderivative or finding an indefinite integral. That means integration we call the antiderivative. That means reverse process of the derivative. So it is called the integrations. Next here I define the indefinite integral. Indefinite integral means its type is, that means integral f of x dx. This type we call it is indefinite. Indefinite means it is no limit. So next that means mainly the integrations we used for the conceptual understanding of integration as a process of finding the total accumulated change given the rate of change summing process. So the process of finding area under a curve over an interval is known as integrations. That means we finding the area under the curve with the interval, we call it as integrations. Mainly integration we used for the calculating volume and area. So definite integral a to b f of x dx, this type of integral we called a definite integral. That means there exists a limit a and b. So integral a to b f of x dx, we call it is a definite integral. You see, integration is a way of adding slices to find the whole. So that means we adding all the slices, so we find the area. That means the integration can be used to find the areas and the volumes. Mainly the main purpose we use the integration for finding the areas and the volumes. So here there is a curve. Now we calculate this area under with the use of integration. Here to find the area under this curve, now we find out the area. That means we may struggle to find the area, but we approximate it using rectangle. That means now we add that means rectangle shape of the slices. So here that breadth is del x. So add up slices of width del x like this, but the answer would not very accurate because it is a very large. All the slices are rectangular, very large. So it is its breadth is del x. So it is not. We add this, it is not come to accurate. So you see, now we see about the small size of the rectangle slices. So add up many small slices, answer is getting better. So we add up the small slices and the length is its breadth is del x. Approximately we take the breadth. So it is a small size of the rectangle shape. It is that means so the breadth is very small. So we take it is we add this, we get the accurate answer. So the curve is y equal to f of x. Here y equal to, here the curve is y equal to f of x. So next as the slices approach 0 in width, the area approaches the accurate. That means you see the slices approach 0 in width. So the slices approach to 0 means so the area approaches the accurate. The area is, that means del x tends to 0. The slice with this del x, therefore the curve is y equal to f of x. Under this curve we take the del x, the every slices it's with this del x. Therefore all the slices it comes to the small sizes, so we calculate the area. So the condition is del x tends to 0. Now you see the water flow and come in this beaker. So integrating the flow, adding up all the little bits of water, so gives us the volume of the water in the tank. So we consider this is the tank. So all the waters is come in the tank. So it is we calculate the volume. So integration the flow, adding up all the little bits of water gives us the volume of the water in the tank. So we calculate the volume of the water by the use of integrating. So with a flow rate of 1, the tank volume increases by x. So here the flow rate of 1 means the tank volume increases by x. So as the flow rate increases, the tank fills faster and faster. That means the flow rate increases. The flow rate means the water fastly come. So the volume is easily fill up and quickly fill up. So you see Riemann sums. Now we discuss about the Riemann sums. Two types of Riemann sums. That means left Riemann sums and right Riemann sums. So left Riemann sums means to make a Riemann sum, one possible choice is to make our rectangles touch the curve with their top left corners. This is called a left Riemann sums. That means here the Riemann sums means there is a two type. One is left Riemann sums and right Riemann sums. So left Riemann sums means to make a Riemann sum, one possible choice is to make our rectangle touch the curve with their top. So it makes that means the touch in the top of the rectangle. So left corners, it touch only in the left corners. This is called a left Riemann sum. So left, that means the left means end rule for Riemann sum means S equal to a1 a2 plus etc an. Therefore S equal to a1 means f of x naught del x plus f of x1, that means next f of x1 del x plus etc. So they f of x minus 1 del x. So next s equal to f of x. Now we add all the functions. Del x is common to del x is in the all the terms. So I take the del x in the outside. Therefore f of x naught plus f of x1 plus etc. f of xn minus 1 into del x. This is the s equal to f of x naught plus f of x1 plus etc. f of x minus 1 into del x. This is the left, that means left end rule for Riemann sum. Here every rectangle shape, every rectangle slices, I take the functions f of x naught, f of x1, f of x2, and with this, that means I take the x1, x2, x3. That means the point is x1, x2, x3. With this del x, the interval starting from a to b. Here I take the functions y equal to f of x. So from this I write the s equal to a1 plus a2 plus etc an, and s equal to f of x naught del x, f of x1 del x plus etc f of xn minus 1 del x. Therefore s equal to f of x naught plus f of x1 plus etc f of xn minus 1 into del x. This is the left Riemann sums. So next, right Riemann sums. Right Riemann sums means, that means to make a Riemann sums. So now we discuss about the right Riemann sums. To make a Riemann sums, one possible choice is to make our rectangle touch the curve with their top. That means every point the curve touch in the right side. So right side is here I tell that. That means to make a Riemann sums, one possible choice is to make our rectangle touch. That means the curve with their top right corners. This is called the right Riemann sums. That means, so here you see all the curve touch in the right point only. So we call it is the right Riemann sums. Next, the right end rule for Riemann sum means s equal to, here I take a1 plus a2 plus etc an. So a1 means here I consider f of x1 del x, a2 means f of x2 del x plus etc f of xn del x. Therefore s equal to f of x1 plus, here every del x is common, so I take the del x in the outside. Therefore I get the equation, we get the equation s equal to f of x1 plus f of x2 plus etc f of xn into del x. This is the right Riemann sums. So now we discuss about the example 9.1. Estimate the value of integral 0 to 5 x 0 integral 0 to 0.5 x square dx using the Riemann sums corresponding to 5 subintervals of equal width and applying left end rule, right end rule, the midpoint rule. So here you see the questions. They ask about the estimate the value of integral 0 to 0.5 x square dx using the Riemann sums. So we, with the use of the Riemann sums, we calculate integral 0 to 0.5 x square dx corresponding to 5 subintervals of equal width, applying left hand rule, right hand rule and a midpoint rule. Here, that means I write the limit. That means the upper limit we take the, lower limit I take the a equal to 0, upper limit I take the b equal to 0.5. Then next they ask about the 5 subintervals, so n equal to 5. So next mainly the integrations means the general format is integral a to b f of x. So here the functions, this one x square we consider the f of x equal to x square. So next the width of the each subinterval. So now we calculate the width of the each subinterval. So the formula is h equal to del x equal to b minus a by n. So here b is 0.5 minus a value is 0 by 5. So 0.5 by 5 means 0.1. Therefore h equal to 0.1. So the partition of the interval is given by the point. So each interval with this h equal to 0.1. So the partition of the interval is given by, now we find out the partitions. So x naught, first I consider the x naught equal to 0. Next x1 equal to the formula is x naught plus h. So x naught value 0, 0 plus 0 0.1, 0 0.1, x2 equal to, that means x1 plus h. That means x1 value is here x1 equal to 0 0.1, 0 0.1, h value is h equal to 0 0.1, 0 0.1 plus 0 0.1, 0 0.2. Next x3 equal to x2 plus h, that means 0 0.2 plus 0 0.1, 0 0.3. Next x4 equal to x3 plus h, x3 value is 0 0.3, 0 0.3 plus 0 0.1 equal to 0 0.4. Therefore 0 0.1, 0 0.2, 0 0.3, 0 0.4, x naught value is 0. So you see here x4 equal to x5 equal to x4 plus h, x4 value is 0 0.4, 0 0.4 plus 0 0.1 equal to 0 0.5. Now we calculate the left hand rule for Riemann sums with equal with the del x. So the left hand rule for Riemann sum we calculate. The question is calculate the Riemann sums. Riemann sums means and next they classify left rule, right rule and the midpoint rule. So this is the left rule. So left rule of the Riemann sum means s equal to f of x naught plus f of x1 plus etc. f of x minus 1 del x. This is the left Riemann rule sums. So s equal to f of x naught means 0, f of 0 plus f of 0 0.1 plus f of 0 0.2 plus f of 0 0.3 plus f of 0 0.4. So we take only 5 intervals. So 1, 2, 3, 4, 5 intervals. We're starting from the 0 x naught values. The x naught value equal to, that means we're starting from x naught, x1, x2, x3, x4, 5 intervals. So x naught value is 0, x1 value is 0 0.1, x2 value is 0 0.2, x3 value is 0 0.3, x4 value is 0 0.4 into del x value is 0 0.1. So the next step, so f of 0 means we substitute. We know that f of x equal to x square. So f of 0 means 0 square plus f of 0 0.1 means 0 0.1 whole square, because we know the functions f of x equal to x square. So that means this 0 0.1 I take the square, 0 0.1 whole square plus 0 0.2 whole square. F of 0 0.3 means 0 0.3 whole square. F of 0 0.4 means 0 0.4 whole square into 0 0.1. The next step, 0 square means 0 plus 0 0.1 whole square means 0 0.01 plus 0 0.2 whole square means 0 0.04 plus 0 0.3 whole square means 0 0.09 plus 0 0.4 whole square means 0 0.16 into 0 0.1. Now we add all the decimals value, so we get the answer 0 0.3 into again 0, multiply the 0 0.1. So 0 0.3 into 0 0.1 means, that means we get 0 0.03. So this is the left Riemann sums answer. Therefore s equal to 0 0.3. So therefore integration of integral 0 to 0 0.5 x square dx is approximately calculate 0 0.03. This is a sum for left Riemann sums. This is the answer for left Riemann sums. Now we calculate the right hand rule for Riemann sums with equal with the del x. So here this is the formula for right hand Riemann rule. So here s equal to, that means we starting the we now take the x naught. So we consider only x1, x2 plus etc. f of xn. So we write it x1 means the x1 point means 0 0.1, so f of 0 0.1 plus f of x2 means 0 0.2, f of 0 0.2 plus x3 means f of 0 0.3 plus x4 means f of 0 0.4 plus x5 means f of x5. So f of 0 0.5 into, we know that with the width of the each interval is 0 0.1, so del x equal to 0 0.1 I substitute. Therefore f of x means x square, so f of 0 0.1 we write it 0 0.1 whole square plus f of 0 0.2 0 0.2 whole square plus f of 0 0.3 0 0.3 whole square plus f of 0 0.4 0 0.4 whole square, f of 0 0.5 0 0.5 whole square into 0 0.1. Next 0 0.1 whole square means 0 0.01 plus 0 0.2 whole square means 0 0.04 plus 0 0.3 whole square means 0.09 plus 0 0.4 whole square means 0 0.16 plus 0 0.5 whole square means 0.25 into 0 0.1. So we add all the decimal values, so 0.55 into 0 0.1, so 0.055. This is the answer for the right hand rule for the Riemann sum. Therefore integral 0 to 0.5 x square dx is equal to 0.055. This is the answer for right hand rule for Riemann sums. Next we calculate the Next we calculate the midpoint rule for Riemann sums with the equal with the del x. So here the midpoint rule for the Riemann sum means this is the formula s equal to f of x0 plus x1 by 2 plus f of x1 plus x2 by 2 plus etc f of xn minus 1 plus xn by 2 into del x. So here x0 means we know that x0 plus x1 by 2 means x0 means 0 plus x1 value is 0.1 by 2. So 0.1 by 2 means 0.05. Next x1 plus x2 by 2 means 0.1 plus 0.2 means by 2 means 0.3 by 2 0.15. So next x2 plus x3 by 2 means, that means we substitute the x2 point x3 point by 2 means 0.25. next x3 plus x4 by 2 0.35, x4 plus x5 by 2 0.45. so now I substitute the midpoint. So s equal to, in the formula we substitute in the formula f of 0 point, that means f of x1, that point we substitute the f of 0.05 plus f of 0.15 plus f of 0.25 plus f of 0.35 plus f of 0.45 into 0.1. so the first point means we know that f of x0 plus x1 by 2 its value is 0.05, and the next x1 plus x2 by 2 its value is 0.15. next x2 plus x3 its value, x2 plus x3 by 2 its value is 0.25. next x3 plus x4 by 2 its value is 0.35. next x4 plus x5 by 2 0.45 into 0.1. next we know that the functions f of x equal to x square, so 0.05 whole square plus 0.15 whole square, 0.25 whole square, 0.35 whole square, 0.45 whole square into 0.1. so whole square means 0.0025 plus 0.15 whole square means 0.0225. next 0.25 whole square means 0.0625 plus 0.35 whole square means 0.1225 plus 0.45 means 0.2025 into 0.1. now we add all the values in the within the bracket. so here 5 values we added, so the answer is 0.4125 into 0.1. therefore we multiply these two decimals, we get the answer 0.04125. this is the answer for midpoint rule of the Riemann sum. therefore integral 0 to 0.5 x square dx is approximately equal to 0.04125. So find an approximate value of integral 1 to 1.5 x dx by applying the left hand rule with the partition 1.11, 1.1, 1.2, 1.3, 1.4, 1.5. you see, find an approximate value for the integral 1 to 1.5 x into dx by applying the left hand rule with the partition. this is the partitions. so now here you see the functions, you see the integral, given integral is integral 1 to 1.5 x dx. this is the given integral. so here we take a equal to 1, b equal to 1.5, that means the lower limit I take the, usually the integral we mentioned by integral a to b f of x dx. so a means lower limit, b means upper limit. so a equal to 1, b equal to 1.5, n equal to, that means n value is 5. therefore f of x equal to, so f of x means this is f of x, f of x equal to x. therefore h equal to del x equal to, so h equal to del x means the formula is b minus a by n. so here h equal to del x equal to b minus a by means b value is 1.5. so 1.5 minus 1 by 5. so in the next step 1.5 minus 1 means 0.5 by 5. so this 5 divide the 0.5, so 0.1. therefore the width of the each partition is, each interval is 0.1. therefore h equal to 0.1. given partition, this is a partition, so I write the first value, that I take the x equal to 1. so x, that means x not equal to 1, x1 equal to 1.1, x2 equal to 1.2, x3 equal to 1.3, x4 equal to 1.4, x5 equal to 1.5. so first I take the x0 means the lower limit, we take the x0 equal to 1. next the given partition x1, x2, x3, x4, x5, the upper limit is x5. so now we calculate, you see the questions they will ask about the left hand rule with the partition. so the left hand rule for the Riemann sum means left hand rule for Riemann sum equal to S equal to f of x0 plus f of x1 plus etc plus f of xn minus 1 into del x. You see f of x0 equal to 1, so f of 1 plus x1. F of x1 means x1 value is 1.1, so f of 1.1 plus x2 value, x2 means 1.2, f of 1.2 plus x3 means f of 1.3 plus x4 means f of 1.4 into 0.1. so next we know that f of x means f of x equal to, that means f of x equal to x, so f of 1 means 1 plus f of 1.1 means 1.1 plus f of 1.2 means 1.2, f of 1.3 1.3, f of 1.4 1.4, so into 0.1. now we add all the decimal values within the bracket, so we got the answer 6.0 into 0.1, so therefore the answer is 0.6. so therefore 0.6 this is a left hand rule for Riemann sums. So therefore we mentioned by integral 1 to 1.5 x dx equal to 0.6. This is a left hand rule for Riemann sums. So second problem, find an approximate value of integral 1 to 1.5 x square dx by applying the right hand rule with the partition 1.1, 1.2, 1.3, 1.4, 1.5. Here you see the questions. Find an approximate value. They ask about the approximate value of the integral, that means 1 to 1.5 x square dx by applying the right hand rule. So with the partition, so we know that right hand rule. So now we calculate this, we take the general form of the integral is integral a to b f of x. So a means lower limit, a equal to 1, b equal to upper limit 1.5, n equal to 5, f of x equal to the given functions x square. Therefore h equal to del x equal to b minus a by n. So here b value is 1.5, 1.5 minus a value is 1 by 5. So next 1.5 minus 1 means 0.5 by 5, that means 0.1, h equal to 0.1. therefore the given partition means I take the first lower limit, I take the x0, so a equal to 1 is the lower limit, b equal to 1.5 is the upper limit. So this lower limit I consider x0 equal to 1. Next this is the x1, x2, x3, x4, x5. x1 equal to 1.1, x2 equal to 1.2, x3 equal to 1.3, x4 equal to 1.4, x5 equal to 1.5. so this is the given partition. So now we apply that they ask about the right hand rule. So the right hand rule for Riemann sum means this is a formula, s equal to f of x1 plus f of x2 plus etc plus f of x and del x. So s equal to f of 1.1, that means write it. So left means we consider only x1, x2, x3, x4, x5. so that means we leave it the x0. so this is a that means right Riemann means right hand rule means we leave it the x0 value. So remaining intervals we take x1, x2, x3, x4, x5. left means we consider the x0, we leave it the last x5 interval. So but here in this problem they ask about the right hand rule of the Riemann sum. So right hand rule means that means we leave the x0, so we leave the, that means we leave the starting point x0 values, the remaining values we take it x1 equal to 1.1, x2 equal to 1.2, x3 equal to 1.3, x4 equal to 1.4, x5 equal to 1.5. so therefore s equal to f of x1 plus f of x2 plus etc f of xn into del x. therefore s equal to f of, that means x1 means 1.1 plus f of 1.2 plus f of 1.3 plus f of 1.4 plus f of 1.5 into del x. therefore f of x means x square. So we write f of 1.1 means 1.1 whole square, 1.2 means 1.2 whole square, 1.3 means 1.3 whole square, 1.4 whole square, 1.5 whole square into del x means 0.1. so next to 1.1 whole square means 1.21, 1.2 whole square means 1.44, 1.3 whole square means 1.69, 1.4 whole square means we multiply the 1.4 whole square means 1.4 into 1.4, that means 1.96. so next to 1.5 whole square means 2.25. so next into 0.1. so next we add all the decimal values within the bracket. So the answer is 8.55 into 0.1. so we multiply the 8.55 into 0.1 means the x equal to 0.855. this is a right hand rule for Riemann sums. Therefore integral 1 to 1.5 x square dx equal to 0.855. this is the answer. This is the answer for right 10 rule for Riemann sums. Next, the third problem. Find an approximate value of integral 1 to 1.52 minus x into dx. Applying the midpoint rule with the partition 1.1, 1.2, 1.3, 1.4, 1.5. You see the questions, find an approximate value of integral 1 to 1.52 minus x dx. So we calculate this integral applying the midpoint rule with the partitions. We apply the midpoint rule. So here that means the lower limit we take the a, upper limit we take the b. Generally the general form of the integral means integral a to b f of x dx. So a to b means a equal to 1, b equal to 1.5, f of x means 2 minus x. So I substitute a equal to 1, b equal to 1.5, and next they ask about the, you see the intervals 1, 2 partition. That means here 1, 2, 3, 4, 5 partitions. Therefore n equal to 5. Next f of x equal to 2 minus x. Therefore h equal to, now we calculate the width of the each interval. So h equal to del x equal to, the formula is b minus a by n. So b value is 1.5 minus a value is 1 by 5. So 1.5 minus 1 means 0.5 by 5. That means 0.1. Therefore h equal to 0.1. Now I write it the given partition. So first I write the lower limit. Lower limit I write it the x0. So x0 equal to 1. Next I write the every partition, the started from x1, x2, x3, x4, x5. So x1 equal to 1.1, x2 equal to 1.2, x3 equal to 1.3, x4 equal to 1.4, x5 equal to 1.5. So next midpoint rule for Riemann sum. Now we calculate the midpoint rule. So we know that midpoint rule, s equal to f of x0 plus x1 by 2 plus f of x1 plus x2 by 2 plus etc. f of xn minus 1 plus xn by 2 into del x. Here x0 plus x1 by 2 means x0 plus x1 by 2 means x, we know that x0 value 1 plus x1 value is 1.1. I substitute by 2. So 1 plus 1.1 means 2.1 by 2. So 2.1 by 2 means it's a 1.05 answer. Next we calculate the x1 plus x2 by 2. So I substitute the x1 value 1.1 plus x2 value is 1.2 by 2. So equal to 1.1 plus 1.2 equal to 2.3 by 2. So 2.3 by 2 means 1.15. So next we calculate the x2 plus x1 plus x2 by 2. Next x2 plus x3 by 2. So x2 plus x3 by 2 means here x2 value is 1.2 plus x3 value is 1.3. So by 2. So 1.2 plus 1.3 means 2.5. 2.5 by 2 means 1.25. Next x3 plus x4 by 2. So x3 value is 1.3 plus x4 value is 1.4 by 2 equal to, that means 1.3 plus 1.4, 2.7 by 2 means 1.35. Next x4 value is 1.4 plus x5 value is 1.5 by 2. So 2.9 by 2 means it is a 1.45. This is the answer. So now we substitute every values, every mid in this values in the functions. So you see here s equal to f of 1.05 plus f of 1.15 plus f of 1.25 plus f of 1.35 plus f of 1.45 into del x. Now s equal to, that means now we substitute the functions. We know that f of x equal to 2 minus x. So x means 1.05. So 2 minus 1.05 plus f of 1.15 means 2 minus 1.15 plus f of 1.25 means 2 minus 1.25. f of 1.35 means 2 minus 1.35. f of 1.45 means 2 minus 1.45 into 0.1. So next step we add that means 2 plus 2 plus 2 6, 6 plus 2 8, 8 plus 2 10 minus, that means now we add the minus 1.05 minus 1.15 minus 1.25 minus 1.35 minus 1.45. So we get the answer minus 6.25 into 0.1. So we subtract the 6.25 from 10. So therefore 3.75 into 0.1. So this the answer is 0.375. This is the answer. Therefore integral 1 to 1.5 2 minus x into dx equal to 0.375. This is the answer. So now limit formula to evaluate integral a to b f of x dx. So Now we evaluate the, that means we calculate the limit formula to evaluate integral a to b f of x. So here h, we know that h formula, this is the, you see this is the right limit of the Riemann sum, because every curve touch in the right side. So this is the right limit. Now h equal to, that means width of the interval equal to b minus a by n. Suppose the width tends to 0, width comes to small means n tends to infinity. So therefore now s equal to a1 plus a2 plus etc. an. So s equal to, that means h into f of a plus h into f of a plus a2 represented by h into f of a plus h, a3 represented by h into f of a plus 2h plus etc. h into f of a plus n minus 1 into h. So the next step, s equal to, we take the h from the outside. So h into f of a plus f of a plus h, f of a plus 2h plus etc. f of a plus n minus 1 into h. So in the next step, so this is the, that means limit formula to evaluate integral a to b f of x dx. You see this is the curve touch in the right side. So this is the right end of the Riemann sum. So here the function I consider y equal to f of x. This is the width of the interval b minus a by n, and h tends to 0 means the width comes to small, the width comes to 0 means n tends to infinity. Therefore s equal to a1 plus a2 plus etc. plus an. Therefore s equal to h into f of a plus h into f of a plus h, h into f of a plus 2h plus etc. h into f of a plus n minus 1 into h. Therefore s equal to h into f of a plus f of a plus h plus f of a plus 2h plus etc. plus f of a plus n minus 1 into h. This is a interval function. So here s equal to h into summation f of a plus I h equal to s equal h into summation f of a plus I equal to 1 to n f of a plus I h. That means h means b minus a by n. Summation I equal to 1 to n f of a plus I into h value is b minus a by n, which implies s equal to limit n tends to infinity b minus a by n summation I equal to 1 to n f of a plus I into b minus a by n. So therefore integral a to b f of x dx equal to, that means equal to, we know that s value is integral a to b f of x dx equal to limit n tends to infinity b minus a by n summation I equal to 1 to n f of a plus I into b minus a by n. So the next step, integral a to b f of x dx equal to, we write it, limit n tends to infinity b minus a by n summation r equal to 1 to n f of a plus r into b minus a by n, I write it. So next step, integral a to b f of x dx equal to limit n tends to infinity b minus a by n summation r equal to 1 to n f of a plus b minus a into r by n. So therefore integral 0 to 1 f of x dx equal to limit n tends to infinity 1 by n summation r equal to 1 to n f of r by n. This is the answer for integral 0 to 1 f of x dx value. So therefore integral 0 to 1 f of x dx equal to limit n tends to infinity 1 by n summation r equal to 1 to n f of r by n. This is the answer. So see 1 plus 2 plus 3 etc. n equal to, the formula is n into n plus 1 by 2 summation k equal to, that means generally we take 1 plus 2 plus k, we take the summation k equal to n into n plus 1 by 2. Next to 1 square plus 2 square plus 3 square etc. plus n square equal to n into n plus 1 into 2n plus 1 by 6, or summation k square equal to n into n plus 1 2n plus 1 by 6. Next 1 cube plus 2 cube plus 3 cube etc. plus n cube equal to n into n plus 1 by 2 whole square. So this is a formula for, that means 1 cube plus 2 cube plus 3 cube up to etc. n cube equal to n plus n into n plus 1 by 2 whole square, or summation k cube equal to n into n plus 1 by 2 whole square. Now we discuss about the example 9.2. Evaluate integral 0 to 1 f of x, that means x dx as the limit of a sum. So the question is evaluate integral 0 to 1 x dx as the limit of a sum. So now we evaluate this integral. So here here we write that means we compare this integral with the general form of the integral. The general form of the integral is integral a to b f of x dx. So a to b means a equal to 0 lower limit, b equal to upper limit, next f of x equal to x. So now integral 0 to 1 f of x dx formula is limit n tends to infinity 1 by n summation r equal to 1 to n f of r by n. So therefore f of x equal to x. So f of r by n means here x equal to f of x equal to x. So f of r by n means r by n. Therefore integral 0 to 1 x dx equal to limit n tends to infinity 1 by n summation r equal to 1 to n. That means f of r by n means we write it r by n. Therefore limit n tends to infinity 1 by n into we write it this. So 1 by n we write in the outside because the limit for the summation for only r values. So I write it 1 by n into 1 by n summation r equal to 1 to n into r. So the next step limit n tends to infinity 1 by n square summation r equal to 1 to n r equal to limit n tends to infinity 1 by n square. That means this r now that means that I run the value, I give the value r equal to 1, r equal to 2. So 1 plus 2 plus up to etc. we write it n. So 1 plus 2 plus etc. n. Therefore limit n tends to infinity 1 by n square into here 1 plus 2 plus n means sum of the natural numbers equal to, we know the formula, n into n plus 1 by 2. I substitute here sum of the natural numbers 1 plus 2 plus at the finite number. So 1 plus 2 plus 3 plus up to etc. plus n means n into n plus 1 by 2. Therefore n cancelled. So 1 by n into n plus 1 by 2. Therefore that means 1 by 2 into n plus 1 by n. Limit n tends to infinity 1 by 2 into n plus 1 by n. Therefore integral 0 to 1 x dx equal to limit n tends to infinity. That means this value is 1 by 2 into, that means n plus 1 by n means n divide the numerator. So n by n plus 1 by n. That means I write it 1 by 2 into limit n tends to infinity. N by n means 1. So plus 1 by n. Now I substitute the limit n tends to infinity means I substitute n equal to infinity. So 1 by 2 into 1 plus 1 by infinity. 1 by infinity is 0. Therefore integral 0 to 1 x dx equal to 1 by 2. This is the answer for the our given integral. Therefore this is the answer. Therefore integral 0 to 1 x dx equal to 1 by 2. Next we discuss about the example 9.3. Evaluate the integral 0 to 1 x cube dx as the limit of your sum. So now we evaluate this integral. So we compare this integral with the general form of the integral means integral a to b f of x dx. So a means lower limit, a equal to 0, b equal to 1, f of x means x cube. So integral 0 to 1 f of x dx equal to limit n tends to infinity. That means the formula is integral 0 to 1 f of x dx equal to limit n tends to infinity 1 by n summation r equal to 1 to n f of r by n. So here f of x equal to x cube. The given function is f of x equal to x cube. So which implies f of r by n equal to r by n whole cube. That means r cube by n cube. So integral 0 to 1 x cube dx equal to limit n tends to infinity. I substitute 1 by n summation r equal to 1 to n. F of r by n means r by n whole cube means r cube by n cube. So which implies integral 0 to 1 x cube dx equal to limit n tends to infinity 1 by n into 1 by n cube summation r equal to 1 to n r cube. So the next step, now I take the n cube from the summations because the summation only for r values. So the n cube I take in the right, that means outside. So 1 into 1 by n cube summation r equal to 1 to n r cube. So in the next step 1 by n into 1 by n cube means 1 by n power 4. Limit n tends to infinity 1 by n power 4. I substitute the value r equal to 1 means 1 cube plus 2 cube plus etc. plus n cube. So limit n tends to infinity 1 by n power 4 into, so the sum of the cube of the answer means n into n plus 1 by 2 whole square. This is the answer for 1 cube plus 2 cube plus etc. n cube. N into n plus 1 by 2 whole square. So in the next step limit n tends to infinity 1 by n power 4 into n square n plus 1 whole square by 2 square means 4. So equal to limit n tends to infinity. So in the next n power 4 n square cancelled. So 1 by n square into n plus 1 whole square by 4. So the next step So in the next step, limit n tends to infinity 1 by 4 into n plus 1 whole square by n square. So 1 by 4 we can write in the, that means we take in the outside, because the limit only for n tends to infinity, so n terms only write in the, that means here the remaining terms I take the constant term, I take the outside. So 1 by 4 is a constant, I write in the outside. So 1 by 4 into limit n tends to infinity n plus 1 whole square by n square. Now 1 by 4 limit n tends to infinity n plus 1 whole square, n plus 1 by n whole square. So you take now this denominator, divide all the numerator term, n by n plus 1 by n whole square. So 1 by 4 limit n tends to infinity, that means n by n means 1 plus 1 by n whole square. So in the next step we take n tends to infinity, n equal to infinity, we substitute. So 1 by 4 into 1 plus 1 by infinity, 1 by infinity is 0, so 1 by 4 into 1 plus 0, that means 1 by 4. So therefore integral 0 to 1 x cube dx equal to 1 by 4. This is the answer for the 1 by 4 is the answer for integral 0 to 1 x cube dx. So next example 9.4, evaluate integral 1 to 4 2x square plus 3 into dx as the limit of your sum. So here that means the question is evaluate integral 1 to 4 2x square plus 3 into dx. So now that means now we will find out the answer for this integral. So I compare the general integral, I write the given formula, that means the formula is integral a to b f of x dx equal to limit n tends to infinity b minus a by n summation r equal to 1 to n f of a plus b minus a into r by n. So here a equal to, that means we compare the integral in the general form of the integral a to b f of x dx. A means 1, b equal to 4, f of x equal to 2x square plus 3. So therefore a equal to 1, b equal to 4, f of x equal to 2x square plus 3. So therefore integral 1 to 4 f of x dx equal to limit n tends to infinity b value b equal to 4 minus 1 by n into summation r equal to 1 to n f of a value is 1 plus b value is 4 minus 1 into r by n. So the next step, integral 1 to 4 f of x dx equal to limit n tends to infinity 4 minus 1 means 3 by n summation r equal to 1 to n f of 1 plus 4 minus 1 means 3 r by n. So next step, f of x equal to, so we know that f of x equal to 2x square plus 3. So I write it f of x equal to 2x square plus 3. So which implies f of 1 plus 3 r by n equal to, that means x means we write it f of x means f of x equal to 2x square plus 3. So f of 1 plus 3r by n equal to 2 into 1 plus 3r by n whole square plus 3. So in the next step, 2 into, that means a plus b whole square means a square plus 2ab, a square plus b square plus 2ab. So a square means 1 square plus b square means 3r by n whole square plus 2ab, 2 into a value is 1, b value is 3r by n. So plus 3. In the next step, 2 into, that means 1 square, 3r by n means 3 square means 9r square by n square plus 2 into 2 3s are 6r by n plus 3. So in the next step, 2 plus next 18r square by n square plus 12r by n plus 3. Therefore f of 1 plus 3r by n equal to 5 plus 18r square by n square plus 12r by n. So this is the f of 1 plus 3r by n. The next step, integral 1 to 4 f of x dx equal to limit n tends to infinity 3 by n summation r equal to 1 to n f of 1 plus 3r by n equal to this functions we substitute 5 plus 18r square n square plus 12r by n. So I write it limit n tends to infinity 3 by n summation r equal to 1 to n. I write it, that means 5 plus instead of f of 1 plus 3r by n, I write it 5 plus 18r square by n square plus 12r by n. So in the next step, limit n tends to infinity summation r equal to 1 to n, that means I write it, that means this n this 1 by n I multiply in the factor. So 15, that means this is a 5 not 15. So 3 by n I multiply in the factor. So 3 by n means 3 into 5 15 by n into 3 into 18 54 r square by n cube plus 3 into 12 means 36 r by n square equal to limit n tends to infinity. Next I take the, that means I take the constant. Here the summation only for r values. So 15 by n is a constant. I write in the 15 by n into summation r equal to 1 1 to n 1 plus next 54 by n cube into summation r equal to 1 to n r square plus 36 by n square into summation r equal to 1 to n r. So the next step, limit n tends to infinity 15 by n. So summation r equal to 1 means 1 plus 2 plus up to etc n means n. So sum of the natural numbers means in the formula is, that means it is we represented by the n. So 1 plus 2 plus 3 up to etc n means I represented the n. Next 54 by n cube into summation r square means 1 square plus 2 square plus etc plus n square. Next 36 by n square means 1 plus 2 plus 1 plus 2 plus up to etc n. Here that means here summation r equal to 1 means we give any numbers, so it is that means here summation r equal to 1 to n means it is a constant, so its value is 1. So here the value comes to 1 here, 1 the value come 1 because there is a summation, no n here, no r value here, so only constant, so summation of the constant means 1, so therefore I represented by 1. So here I substitute, here the value is comes for 1. So 15 by n into 1. So next 54 by n cube into 1 square plus 2 square plus etc plus n square. Next 36 by n square into 1 plus 2 plus up to etc n. The next step 15 by n. And here that means summation 1 we calculate the summation 1 we calculate the n. So n substitute divided, so we cancelled. So 15 plus 54 by n cube into the sum of the square of the terms equal to the formula is n into n plus 1 2n plus 1 by 6 plus 36 by n square into sum of the natural numbers formula is n into n plus 1 by 2. So the next step we write it. So therefore limit n tends to infinity 15 plus 54 by n cube into n plus 1 2n plus 1 by 6 plus 36 by n square into n plus 1 by 2. So the next step 15 plus 54 by n cube n, that means cancelled. So n square into n into, that means so n plus 1, so 1 n cancelled, so n plus 1 2n plus 1 by 6 plus 30 n square cancelled, so 36 by n, so into n plus 1 by 2. So the next step, limit n tends to infinity 15 plus 54 by 6 into n plus 1 into 2n plus 1 by n square plus 36 by 2 into n plus 1 by n. So the next step, limit n tends to infinity 15 plus, that means 9 6 are 54. So the 6 divide the 54, the answer is 9. So 9 into the next step, that means we write it here n plus 1 by n, that means the denominator n square divide the every numerator, so that means n plus 1 by n, next into 2n plus 1 by n plus 36 by 2 means 18 into n plus 1 by n. In the next step, limit n tends to infinity 15 plus, next 9 into, just divide this n, divide the every numerator term, n by n means 1 plus 1 by n, next into 2n by n means 2 plus 1 by n plus 18 into n by n means 1 plus 1 by n. So the next step 15 plus 9 into 1 by n. Now I substitute the limit n tends to infinity, n tends to 1 by infinity is 0, so 9 into 1 plus 0 into 2 plus 0 plus 18 into 1 plus 0 equal to 15 plus, that means 1 plus 0 means 1, 2 plus 0 means 2, 1 plus 0 means 1. So 15 plus 9 into 2 plus 18. So the answer is, that means 9 2s are 18. So 18 plus 18 plus 15, the answer is 51. This is the answer for integral 1 to 4 2x square plus 3 into dx. This is the answer. We complete the class.